Welcome to Aryabhat Center for Theoretical Physics. This is another video on this lecture series Mechanics 1, and topic of this video is variation of G with altitude, depth and latitude. How we can find the gravitational acceleration at some height. Suppose there is an object which has mass m, which is height h from the surface of the earth. So we have to find gravitational acceleration at A. Also we have to find the gravitational acceleration beneath the surface of the earth at D, distance below the surface of the earth at point B. So how we can calculate the gravitational acceleration at some altitude, some depth and also at some latitude lambda. So first of all, the gravitational force at point S, which is the surface of the earth, Fs, is G m E m divided by r e square. Here r e is the radius of the earth. Now the gravitational force experienced by the object A on this point H due to the earth Fa is G m E m and total distance Re plus H whole square. This is the gravitational force at point S, which is the earth surface, at point A, which is above the earth surface at h height. Now we know that gravitational acceleration Gs is equal to F S divided by m. This gravitational acceleration at the earth surface, and it is simply G m E divided by Re square. It means it is G naught, which is 9.8 meter per second square. Now also Ga is Fa divided by m, which is G m E Re plus H square. This is Ga. Now Gme, we can write this equation as Gme equal to G naught Re square. Now we plug this one into this equation and we will get G naught Re square divided by Re plus H square. Now we can take Re out of this bracket and we will get Re 1 plus Re square 1 plus Re square, which is Ga. Now we can cancel Re square and we will get this is the equation we will get after the cancelling Re square from numerator and denominator. Now we can write this equation as Ga is equal to G naught 1 plus H divided by Re to the power minus 2. Now we can use binomial expansion, and when we use binomial expansion we will get 1 minus 2 H divided by Re. This is the gravitational acceleration due to earth above the height h at point A, and here h must be too smaller than Re. It means h is very small compared to Re. This is the gravitational acceleration at point A. Now same way we can find gravitational acceleration beneath the Earth's surface at depth d, and GB is equal to G naught divided by RE, and RE minus D. RE minus D. This is the gravitational acceleration inside the Earth at the depth d. And for the latitude lambda, we will get G lambda is simply G naught plus omega square and RE square sine square lambda. Here omega is angular speed of the Earth or rotational speed of the Earth. This is the gravitational acceleration at latitude lambda. So these are the three variation of gravitational acceleration: one at height h, one at depth d, one at latitude lambda. So this is how we can use this equation and find the gravitational acceleration at a specific location dependent on whether it is altitude, depth or latitude.